Okay, come on, step on the scale. Step on the scale. Let's have a look. Don't touch anything. 28 kilos. Okay, thank you very much.
Your turn.
My turn. No, thank you. Okay, second try. This is a 4x80 amplifier. 1.55 kilos. Okay? And this is a 4x75 amplifier. 16.75 kilos. Hello lovely people. I was postponing this video about this amplifier because, to be honest, I have no idea how to start it. I had so many different options about making this video, and especially making the thumbnail. I wanted to name it like the best amplifier in the world for me or whatever. However, I think I'm gonna do this very simple. I'm gonna try to curb my enthusiasm and do this as I would do any other video for any other amplifier. So in front of us here today we have the holy grail of Alpine amplifiers, the MRV-F900, which is an F1 status line amplifier. So for those that don't know, Alpine makes various different lines of amplifiers and they have their different naming schemes. However, once in a blue moon, once every, I don't know, 20 years or so, they do release F1 status line of gear, which is amplifiers, source units, speakers, subwoofers, processors, and everything else. This amplifier, together with all the other gear, were released in 2001. And what the F1 status line supposed to represent, it was supposed to give us a taste of the best available technology at that time. So this amplifier, together with the DSP, speakers, subwoofers, and everything, supposed to be the best that you can get at early 2000s. So for this amplifier, I would like to say huge thank you to Frank, because this is Frank's and he sent it to me because when I started to measure all the Alpine amplifiers, we saw that the V12s perform exceptionally good, and he bought this for himself. However, he never used it because of the bulk, the size, the inconvenience, and to be honest, he has much better stuff laying around. So he sent it to me. This amplifier, even if the box is a little bit tatty, it is brand new. That means that it wasn't run, it wasn't connected, it wasn't done anything with it for close to 25 years. So you can see it is packed. It does have everything original as it came from the factory. So for example, this, see, in plastic, everything is wrapped. Under this, we do have original mounting hardware with hex keys. We have some sticky stuff or something. This is an original 25-year-old fuse for this amplifier. Now, we don't like these fuses, but it is the included. We have a few clips here. There is another trim piece that goes in the back of amplifier. Again, everything is packed. So Frank, you made my day. You made an Alpine's fanboy dream come true. Let me take it out because I cannot do it with one hand. This amplifier weighs a ton. There we have it. I'm not gonna put these trims yet because there's literally no point. Basically, one of them goes in the very back, and this one covers the front and it makes a very stealth look. So what we're gonna do in this video, we will have a look at this amplifier as it is. I'm gonna show you the insides. We're gonna talk about why is it the way that it is, why is it so big, so huge, and so heavy. We will have a look at objective measurements data as always. I really don't care how long this video is because this video is gonna be for me. And we'll compare this amplifier with some other ones. So for example, these ones and these ones. For those that may be new to my channel and not following, I have this recall literally just for the scale. I'm not going to show you the measurements, but I want to show you the scale of this amplifier because both of these amplifiers are the same power rating. Look at that. This is a Class D, rated 4 times 80 watts. This is rated 4 times 75 at 12 volts and 4 times 100 at 14.4 volts. So we can say kind of the same rating. And this is the evolution of technology. Now, obviously, I'm not saying that they're on the same level performance-wise. I just want to show you the size. The other amplifiers that we will be comparing is this Alpine 3554, which is the cleanest amplifier that I have. This is rated about 4 times 60 watts. The second one is Alpine MRV-F900, which after the bias adjustment is clean as hell as well. So basically these two are the cleanest amplifiers that I have. And again, it is rated about 4 times 60 something. It does a bit more. So in reality, it's very similar power for all 4 of these amplifiers. On paper at least. Probably this is going to do more because all Alpines do more than rated. And on this side, we have 2 kind of modern amplifiers, which is Audison Quattro. I think it's been discontinued, and I will do a separate video on this amplifier, but it does cost about £1,000 brand new. Now it's a bit less, probably like, I don't know, 400 or 500 you can find them. And it is considered, apart from the Thesis series, this is considered to be the cream of the crop from Audison brand. And this is US Amps SQ442, which I have a full review on. This amplifier is rated 4 times 180, and I just want to show it is a Class AB as well, and I just want to show you again the scale and the size of these 2 amplifiers. So the US Amps has about 3 times more power compared to the Alpine. And the Alpine is huge. It's a behemoth of an amplifier. Let me put this back. So this amplifier probably goes without saying, it is a Class AB amplifier, because at that time, I don't think Alpine did Class D amplifiers, at least 4 channels. I think it was the monoblock. I'm not sure when the PDX series came out, but it was before that when the V12s were on the high horse. Now, it does look gorgeous. Oh my God. V12, absolutely brand new, not a single scratch on it. So the story of this amplifier, as I mentioned, Frank got it, he never tested it, he never used it for anything, it was sitting in the box. When he sent it to me and I received it, I powered it on and it went into protection straight away. So it was not working. Now, it's not surprising when an amplifier 25-year-old sitting in storage has some kind of a problem. I thought maybe it's going to be a cap or something. Leaking capacitors is kind of known. For example, this 3.5 had a few leaking capacitors that I had to replace. So it wasn't really surprising. Obviously, it made me sad, but I knew that it will be fixable. So what I did, I sent it to Sam Bervids, and he found a very interesting and weird fault with it.
This is one of the biggest and nicest sounding amplifiers that Alpine ever made. The customer states for this one that when you try and power it up, it just draws excessive current and goes into protect. So we switch on the power supply and I'm going to allow something like 10 amps in to start with. When I hit the remote, let's see what happens. Remote going on now. It's clicking, we have relays engaging, we have constant current light flashing here, which means that every attempt at power up, this thing's attempting to draw more than 10 amps. Just out of interest, so you guys can see, we're going to allow 20 amps in now. This is excessive. This will definitely power up if there's no problem here. Nope, it is eating 20 amps and we have no power up and it's just clicking into protection mode. To draw that much current and not power up, there must be a short somewhere, but it's not on the output devices or drivers. So to speed diagnosis up, let's switch to the thermal camera. We've got 2 capacitors here, and there's another 2 of these capacitors over here for the channels 3 and 4. These are stone cold. This one right here, this looks like it's getting a bit warmer. So these are the capacitors. I've removed both of them because the client wanted me to replace all 4 for good measure. However, both of them read perfectly fine and are not shorted. If we put our multimeter across the pads where the capacitor was, we can see that there's actually a dead short there. Uh-oh. There's our problem. Shorted rectifier. The capacitor itself was not the issue. It was getting hot because it was being fed with AC through this shorted rectifier diode. So with the diodes changed, I'm pretty confident we've got everything back in the heatsink, including these capacitors soldered back in. Let's turn the power supply on and let's hit the remote and see whether we have excessive current draw again. 3, 2, 1. Powering up now. We have a big spike of current to charge the rail caps, and then we are sitting at 2.4 amps idle current draw. Very nice indeed.
So he made that TikTok, he explained how he fixed it. After it came back, it runs flawlessly. So these V12 amplifiers have these screws that you need to undo if you want to change some settings. Usually you have crossovers and everything on other V12s, and basically this lifts up. Here we have a light, just a power light, nothing else. And we do have a few switches. So probably you noticed that this amplifier is kind of split in half, or we have the same on this side and we have the same on this side. When I'm going to show you the insides, you're going to see why that is. But basically this is a dual stereo setup. This is two amplifiers in one chassis. We have first two channels on this side, kind of half of the amplifier, and the second two channels on this side. In regards to the settings, this amplifier was supposed to be used with a DSP. I don't remember the actual model number, but at that time Alpine came out with a DSP. And the only settings that you have is your gain. So we have nominal 1 volt, and on minimum, I think it needs 8 volts. And we have a gain knob for each individual channel. So channel 3 and channel 4 and channel 1, 2 on that. And the only knob we have is if we want to use it in normal mode or in bridge mode. And that's it. No crossovers, no infrasonics, absolutely nothing. This is a direct circuit that has absolutely nothing in the signal path. RCAs come in, speaker level comes out. Like for example, this V12, the 409, it does have quite a lot of in the preamp circuit. You have your high pass, you have your low pass for channels 1, 2, 3, 4, and then here on the top we do have all the settings and gain. Some other Alpine amplifiers do have a single band of parametric EQ as well. This 35 series, since it was one of the first that Alpine released, has a fixed high pass and low pass. It's not really adjustable, the filter. You can just select high pass, low pass, and off, mono stereo, and a gain knob, and that's pretty much it. This one, the Status, has absolutely nothing, and this is what we want from all amplifiers that will be run active, because what is the point of having all that preamp circuit if you're not going to use it anyway? So the standout from this is probably the gain, because as I mentioned, the maximum input voltage on this amplifier is 8 volts. All the other Alpines have 4 volts in, which is kind of unusual because it needs a very strong signal. Now this Audison, I don't really remember, is it 6 or 8 volts in? This US amps as well, I think it needs 6 or 8 volts. I don't really remember the numbers because I'm so excited about this. I don't remember anything about all the other ones. This thing just looks gorgeous. It is a bit dusty, so apologies for that. We do have very typical terminal blocks. You can use either ferrules or fork terminals. Now probably you see that this layout is a bit different than all the other amplifiers, and that's why you need the switch, because usually you have channel 1, channel 2, and when you bridge it you use this and this, but for this amplifier you're using first and third. So bridged mode, the connections are different than all the other amplifiers, and that's why I think it needs that switch. On the input side we have, I do believe this is 6 gauge terminals. It's a bit bigger than 4 gauge, but definitely not a 0 gauge. Remote wire is very small. It says it needs 80 amps fusing, which is a bit surprising because this amplifier 4x75, okay, 4x100, it shouldn't need 80 amps of fusing, but I would assume it's gonna consume a lot of current on idle, because I think this is gonna be heavily biased towards class AB and not run on class B, as these two, as I mentioned in a few videos already, that high power class AB amplifiers, in reality they run more in class B mode, so they have very low idle current. They do have quite a lot of harmonics because of that, because of the thermal capacity of the actual heatsink. But this, weighing like 15 kilos, this heatsink is bloody massive, so it can absorb a lot of heat, and plus it has built-in fans amplifiers, which I didn't know. I think they turn on only when the amplifier gets really hot, because during my testing, it didn't turn on at all. So I think now is the time to turn it over, open it up, and see what we have inside. While I'm undoing the screws, I want to show you something. So where the screws come out, you can see this. This is copper. All of this backplate is made out of copper, exactly the same as the 409. That's me. Hello. And I do believe some head units do have copper outer casing as well. So copper is supposed to be very good for reducing any kind of electromagnetic interference. Let me remove this. It is coated black, but you can see it is a copper plate. And this is the inside of this amplifier. So let me position myself because we're gonna talk about this. Okay, so gut shots. I think this is the most beautiful amplifier that I have ever seen. For reference, I opened up the F409 and the 3554. The US amps we can see there above. The US amps has a PCB of layout just like that because it is kinda, I don't want to say dual stereo, but it does have two power supplies for two sides, because this amplifier is split kind of in half like this, where you have the bottom part for the first two channels and the top part for the other two channels. All the other Alpine amplifiers, the Class AB amplifiers, are following kind of the same, almost the same layout really. It doesn't matter if it's this, or the newest one that I have. Basically, we have the power supply on this side, inductors, transformer, caps, all the output transistors there, and the speakers come out of there. Here is kind of the same. All the preamp circuit is on this side where you have your crossovers and everything, on this one here as well. So for example, you can see that the older 3.5 series has these little ICs, and for example this 409 has everything discrete analog circuit. So some people say that discrete analog circuits sound better than any kind of ICs. ICs obviously save space and is kind of less complicated compared to the discrete stuff, and that's why everything that has discrete stuff is more expensive, because obviously it's more labor intensive. Now for this one, if we have a look, we really don't see any ICs at all. Everything in this amplifier, I'm not 100% sure, but from what I'm seeing, everything in this amplifier is discrete. So instead of looking like this, we're going to split this amplifier in half, and we're going to have a look at only one side, because as I mentioned, this is a dual stereo setup where you have channel 1 and 2 totally separated from channel 3 and 4. So if we're talking about crosstalk is if you're feeding a signal into channel 1, how much of that signal can be picked up by other channels. So obviously when you have a layout like this, all the components, all the output transistors are very close to each other. So for example, these will have the highest crosstalk, and channel this and this will have the lowest crosstalk because they're further away from each other. And obviously the trace is kind of cross, they go next to each other. So the crosstalk is inevitable because everything is kind of crammed into one PCB. When you have a layout like this, when this side is totally separate from this side, there's literally zero crosstalk between these and these channels. It is as if, as I mentioned, is two different amplifiers. Now, why crosstalk is important? If you have a 4-channel amplifier and you're using it on mids and tweets, so for example, for channel 1 and 2, you can use left side mid and tweet. For channel 3 and 4, you're using right side mid and tweet. Since there's literally zero crosstalk between those two, when you play only the left side information, there's absolutely nothing coming out from the right side. Where if you have an amplifier which has everything crammed in, for example, such as this, if you play a signal on one side, something will come out of the other side. That's why we're measuring channel separation on amplifiers. Now, for most amplifiers, like those, this and this is something like 60 to 80 dB. So that means that if you're playing a signal on one side, the other one plays the same signal but 60 to 80 dB down. Now, it might not be audible, but it might be. For this, there's literally zero crosstalk. So let's dive a little bit deeper inside into the circuit. Power input goes through here. We have our input inductors that are kind of filtering the DC, making sure it's very clean. Then we have these bus bars, these massive copper bus bars. They do look bloody awesome. Through these bus bars, the power goes into the transformer. Now, primary caps, I do believe these are these, or maybe these. Are these caps? Yeah, I think it's caps under here. So probably primary caps are here. And here we have our secondary caps, which are bloody huge. This is 50 volts, 10,000 microfarads. So 20,000 microfarads for 2 channels. So basically 10,000 for one single channel, which is just ridiculous. The 409, this one, 8,200 times 2. If we cut it in half, that's 4,100 for one single channel. So this has double the capacity. If we have a look at the US amps, man, I need to do some calculations. So we have 10 caps times 220. So we have 5,500 for one channel, if I'm not mistaken. 5,500 for one channel. That is 3 times as much powerful as this. So this capacity for a single channel is just ridiculous. Everything is so overbuilt that it's not even funny. On this side here on the top, we have our power FETs, 2, 4, 6, 8 FETs for one power supply. On the other side is exactly the same. This little card is all the preamp circuit, which basically is nothing. It's just a few connectors. These are the RCAs that come in here, and we have the adjustment for the gain and switch between bridged and normal mode. And here is our output power transistors. So for 2 channels, we have 6 transistors per channel, where for this, for example, the 409, we have only 2 transistors per channel. So again, it's just ridiculously overbuilt. And you can see all the parts and everything is kind of symmetrical and discrete. So I would imagine we have, again, this is split where channel 1 is at the bottom here and channel 2 is at the top. That's why, again, the crosstalk between the channels is super, super low. And all of these little details, look, the screws are copper. These bus bars are copper. Everything is shielded. Everything is thermally coupled because this goes into the heating over there. Like this plate, copper. There is so much copper in this amplifier that I don't know what the engineers were thinking. Is like, let's put the best that we possibly can. These PCBs, like on all amplifiers, you have one PCB for everything. This is one PCB. This, I don't know if you can see, like here, you see it's split in half. So this is not one PCB. Like you have all of this part is one PCB. All of this, you can see there's a split with these bus bars. There's a second PCB here. This is another PCB. And this is again another PCB, and everything goes with these wires and headers. So the only thing that is kind of transferred from PCB to PCB is with the wires and with these bus bars. Where if you have a look at this one, for example, the traces, yes, they are separated, but they are next to each other and they're going all over the place. That amplifier as well, you can see all the traces going next to each other. So what we can expect is very good performance. At least I hope. Now, the thing is, when I got this amplifier, I got it for more than a month before I even powered it on, because everybody knows that ignorance is bliss. When you have something and you have super, super high expectations of it, you don't want those expectations to be shattered. And I really was scared of it because I know these two amplifiers, their measure are amazing. All the newer ones, compared to those, they're not even close. Like this Audison, it's not even close to those. So based on experience, the more high end you go, it doesn't mean that you will have better performance. But for this Alpine, I do have very high hopes. Now, one thing that I just noticed as well, biasing pots. So this has one pot there, one pot there, on the other side as well. Biasing pots lets us to adjust the bias. On the 409, we have these orange ones. If we have a lot of higher order harmonics, dynamics, if our idle current is very low, we can increase that bias a little bit, reduce the distortion, make the amplifier perform better. However, it will make a bit more heat. That's why now with the readjusted bias, this one runs much hotter than it was, but it's super clean. This 3.5 series, it doesn't have any biasing pot, so you cannot adjust anything. This US amps, again, it doesn't have any biasing pot. You cannot adjust anything unless you like redo the circuit. This one has, and this one has as well. However, what I was reading from the manual, that this amplifier has weird circuits built in. It has a lot of protection, and it has kind of self-adjusting bias depending on the load and the conditions. So I'm not gonna touch the biasing pots because I don't think we will need to do that at all. In regards to the protection circuits, it has basically everything. If something goes bad, it will feel it and it will shut down. That's what happened when I just got it. So it's like over voltage, or low voltage, over current, that kind of stuff. You can see these white thingies over there. Those are relays on the speaker terminals over there. So when you turn it on, when the amplifier is going through the health check mode, those relays disconnect the speaker outputs. When the amplifier knows that everything is good, everything is sorted, only then it engages the relays, and only then you will get output of the speaker output. Amplifier of such level, it should have loads of protection, and Alpine knows that, and it's nice that everything is built in. If you're still with me after all of this rambling, because this is a fanboy rambling about its dream, and I know that a lot of people don't like me rambling a lot, but I just want to share, this is my excitement. When I see something like this, when it is my dream amplifier, I cannot help myself. And I can tell you straight away, it's not that I don't care how it measures. I do care how it measures, but regardless of the measurements and the results, this is gonna be my main amplifier for mid-ranges and tweeters in my car, no matter what. Yes, I can put something like this, which still sounds good. It's tiny, it's small, it doesn't need a lot of power, but when you have something like this, I mean, it would be a sin not to use it. So this will go into my car. Yes, it's highly unpractical. Yes, it's unnecessary. Yes, you can have something better in a much smaller package. But really, I don't care. I want this to be in my car. Even if it's going to be hidden by the panel, even if I'm not going to see it, even if nobody else is going to see it, I still want it just because. I loved one comment that somebody, I don't remember who it was and on what post commented, but the gist of it was that even if a piece of equipment doesn't give you any audible or perceivable gain, it still kind of tickles you inside, and that feeling that you have is worth the extra money and the extra inconvenience that you get by using something like this. So if you're still with me, let's jump into the laptop and I'm going to show you how this amplifier performs and how it compares with all of these. Before I show you the measurements, I just want to show you the thermal imaging. So it's now on. The only thing is on is this blue light, nothing else. On idle over here, you can see it's drawing 3.2 amps at the moment. And I'm gonna wait about 20 minutes or so until it's gonna heat up. And then I'm gonna show you the internals and the outside with the camera. Okay, so this amplifier was running for about half an hour or so. So let's move it to the side. We have our room about 17 degrees Celsius, which is kind of normal temperature. And this is the amplifier running at idle. I haven't, oh, this is my hand. So my hand is 31 degrees. The amplifier itself sits at 28, so about 10 degrees higher than the room temperature. However, it's not rising anymore. And one thing, probably you see yourself that it is literally uniform heating. So on this side we have, okay, so 20, the highest spot 28 degrees. On this side, we have 26. So 2 degrees difference between left and right side. But we have absolutely no hot spots because sometimes on amplifiers, you see like one spot where everything heats up. But for this one, it's uniform. Here, this side, it runs a bit warmer, 26 compared to 24. So this side runs like 2 degrees warmer than the other one. So what I'm going to do, I'm going to turn it off. I'm going to disconnect it, and I want to turn it upside down to see the internals. There we go. So we can see this is the output transistors that are sitting at about 46 to 50 degrees C, which is warm, but nothing too much. Then we see these things, which are the relays. So the relays are warm, and this is, I don't know, a transistor or something. This gets warm. This sits at 28 as normal, and here in the middle, here, something here is kind of warm, 33 degrees. So this is, I have no idea what that is. This is in a power supply, and it's right in the middle. You can see there. Yeah, it does run a bit hot. So, it might be rectifiers? I have no idea. And exactly the same on the other side. And the power supply FETs are cold. Are they? Yeah, they're stone cold. I cannot see anything. So on idle, again, the only thing that heats up is the output transistors and the relays, and everything else runs stone cold. And all the heat, you can see it distributes evenly because of the layout of the amplifier. So again, it's very, very cool to see. So just for reference, I fired up the 409 with the increased biasing, and you can see here the picture is a bit different. So we do have about 29 to 30 degrees, and it's been on about 10 minutes. So probably it's gonna go a little bit higher than that. Yeah, about 30 degrees. And you can see only this side where the output FETs are is heating, and nothing heats up here. So again, it is a smaller chassis. We do have 4 amps draw on this amplifier, but the distribution of heat is very different. And this is another small Alpine that I have, just a 2-channel running my home audio system. That's a power supply that's a bit warm, 27, and you can see it's about 32 degrees. So when you touch it, it's kind of lukewarm. When it's playing, it's a bit hotter. This is heavily biased. This 2-channel is drawing, I think, over 2 amps of current. But yeah, still manageable. You can see this one next to it, it's heavily underbiased. It is on, but it's not even warm while idling. So you can see this is the difference between a heavily biased amplifier and heavily underbiased amplifier. Okay, let's begin. And again, this is going to be a long one because there are going to be a lot of comparisons. So idle current, 3.87 amps, which is the highest idle current I've measured in really any amplifier from the ones that I measured. His, obviously, no audible. His efficiency is abysmal. Class AB, 46%. Nothing special like it's supposed to be. Channel separation. So this is exactly what I was talking about before. Between channel 1 and 2, which are on the same PCB, is 85 dB, which is very good. A lot of other amplifiers will have 60, 80, something similar. So 85 is very good. Between any other channels, there's nothing, because obviously it is a dual stereo, so there's no signal going into the other side. Damping factor. I did measure this output impedance for all 4 channels, which is about 0.01 ohms. And you can see all 4 channels are identical, 20 to 10K, totally flat. And if you transfer this into 4 ohms, you get about 400 for this amplifier, which is very good. For reference, I want to show you something else, is the consistency. So the F900, as I mentioned, all of them are identical. For example, you've seen this before because I showed you these measurements. This is sundown salt, where all 4 channels are quite different and it goes up. This is another sundown where 2 channels are like this, two channels are like this. So the Alpine is super consistent, and it does translate into THD versus level. What I want to show you before is a different amplifier. This is Audison Quattro, so we can see the channels THD plus noise versus level is not the same for all channels, and I did mention that this could be because of the layout of the actual amplifier. So this is Audison Quattro, where you can see two channels are the same. This and this is a little bit different. This, for example, is the Sundown Class AB, where again in the review I said that two channels are measuring like this, the other two are like this, but even between those two channels there is a little bit of a difference. Now the Alpine, what it does is this. You can see that all four channels are measuring identical. Now why that is? Discrete circuits and hand-picked components to match every channel. So every channel is performing almost identical. Now this amplifier, as I mentioned, it is rated at 75 watts, which is here at 12 volts. At 14 volts is 100 watts. So 100 watts is even before the clipping. Clip starts to rise here, which is 110, and 1% it would be something close to 145, 150. So this amplifier is about 30% underrated. It does much more power than it is stated. In regards to the THD itself, you can see that it is below 0.005. In my book, everything below 0.01 is excellent. So we saw some amplifiers like the Atoto that is hovering about 0.1 somewhere here, and we saw others that are somewhere in between, like the US amps are somewhere here. This, it digs deep. The lowest we see, you can see here on these, 0.038, 35, 34, 35. So very, very clean. Now, is it the cleanest amplifier from the all? Let's compare it with some others. From this, I'm going to leave channel 2 because it is the cleanest. I always leave the cleanest channel. So we'll compare channel 2 of this amplifier with all the other ones. This is the 3554, which is, you can see, it is a little bit cleaner at the higher power levels, but obviously it has less power. This is the 409, which is somewhere in between. It does have a little bit more power and it is a little bit cleaner. However, on lower power levels like here, about 10 watts, you can see it's kind of almost identical. Now the Audison is way up there if we're comparing with these three Alpine amplifiers, and the US amps is again much higher than these. From these we can see that the US amps, obviously it has much more power. It's literally a powerhouse. However, cleanliness wise is so far away from these Alpines, it's not even funny. Even the Audison, the best that Audison can offer, apart from the Thesis, it's not comparable to these Alpines. So this is THD plus noise. What I want to see is the THD only without the noise. When I go between these two, some of the graphs drop dramatically and some stay kind of the same. The US amps, it's dominated by THD. That's why this graph didn't change pretty much at all. The Audison, again, it's underbiased and it does have a lot of harmonics, so it does stay over there. However, all of these Alpines drop dramatically. So we see that the F1 Status has a little bit higher distortion compared to the other two, the 3554 and the 409. Those are a bit cleaner, but we're talking the difference between 0.001 and a little bit below and 0.02, which is double the distortion, but this is just literally digging into numbers. So yes, in theory, the smaller amplifiers are a bit cleaner compared to the F1, and F1 has twice as distortion, but you can see the numbers are super small. But if we compare this to Audison or to the US amps, it's not comparable at all. And the F900, the Status, has quite a lot of power, much more than the 3554 and the F409, which is amazing to see. So let's take the US amps and Audison out of the equation because I want to show you something else. If we change this graph instead of watts into volts, and what I'm going to add is the THD of the Helix DSP that I'm running. And the THD is like this. So this DSP, I measured it before, it does 8 volts out, but it is cleanest up to like 6 volts. So if we are thinking that when this DSP reaches about 4 volts, which is here, these two amplifiers are kind of maxed out, which is somewhere here. And basically you can see that the level of THD is almost the same. So this is what I mean when I mentioned before that these amplifiers, THD wise, are on the level of a DSP. On the lower levels, if we have like 1 or 2 volts out of this DSP, yes, the DSP is cleaner, quite a lot cleaner, but if we push this DSP to the max, the cleanliness becomes kind of the same as these 3 amplifiers, which again is very nice to see because there's really no bottleneck in the system. It's gonna be the speakers that have the bottleneck, but electrical signal wise, they're on the same level as the DSP. Now again, if we're gonna add that Audison, it's I don't know, it's not comparable. Like if you're using this Audison amplifier or this US amps amplifier, there's absolutely no need to use something like the Helix DSP because your bottleneck in electrical signal is going to be the amplifier, and you can see it's pointless to use a DSP of such level for these two amplifiers. Only when you come down to the amplifiers of the level of these Alpines, you can utilize really the DSP. So it's just a funny thing that I wanted to show you that, again, these amplifiers are as clean as a DSP. Now let's go and have a look at all the other measurements. What we're going to start with is 1 kilohertz sine tone. So 3554, which is the cleanest amplifier that I have, it does have quite a few harmonics here. And again, on this amplifier, I cannot adjust the bias. So it could be that the biasing issue is a little bit. And the lowest harmonic is -105. The F409 is here, which has very similar performance, a little bit more noise. You can see the floor noise is a bit higher. However, it's only 2 harmonics. Now I'm going to show you the Audison, which is just horrible. The US amps is even worse. And the F900 Status is here. So it does have a little bit higher harmonic. However, it's just the second harmonic and nothing else. This is, I don't know if it's harmonics, it's probably just a little bit of noise, but it's like 110, 112, 115. So we have literally 1 second harmonic at -97, and that's it. And that's what I mean, that 305 is a bit cleaner because it's lower floor noise, and even the 409 is a bit cleaner. Now, I'm not sure why this Status has higher floor noise. Maybe it has to do with the signal generator in the quantasylum that on higher output levels can have a little bit more noise. Maybe that's the issue. Or maybe it's just the fact that, yeah, the sad reality is that both of those smaller amplifiers are a tad bit cleaner than the Status. But the Status, again, is just 1 harmonic and nothing else. Amazing to see. The second comparison I want to make is the 18 and 20 kilohertz sine tone. That I said, to me, this measurement defies the SQ of an amplifier because what we want is good higher frequency performance on it. This is the cleanest high frequency performance that I've ever seen in any amplifier. We can see there is literally no harmonics. This is the power supply, and we have this 2 kilohertz tone here at -105. The 409 is a little bit worse, we can see, noise-wise and harmonics, but still the harmonics are here -92. The Status is almost kind of the same as the 409. It does have a little bit less harmonics, which is minus 100. So yes, for high frequencies, it's a super clean amplifier. And again, this is the power supply, and this is exactly what I want you to see. So the 3.5 is a little bit cleaner than the Status, but again, as I mentioned, I don't care. I will be running this. Now, for reference, the Audison is, yeah, it's bad. I mean, it's not bad. It does have the lowest harmonics at minus 80, which is a very good performance. But you can see all of this. I don't know what that is. The power supply is lower at 30 kilohertz or so. So yeah, the Audison, it's a huge difference. And when you consider that you can get this Audison and this Alpine for almost the same price, yeah, it's just inconvenience about the space. The US amps, it's not even comparison. As I mentioned, it's highly underbiased, and the high frequency performance for this amplifier is not great at all. So in general, high frequency performance, amazing. If we're talking numbers on a little bit bigger scale, we have THD of 0.0015 for this amplifier, which is, you can see, clean as a whistle. The other thing that I want to show you is the intermodulation at 60 and 7K. So you can see 7K, there's nothing. And at 60, we have literally one harmonic at minus 98. Again, super clean. Exactly the same we see with a multitone distortion, where we have 18.7 bits of clean signal. There's literally no noise, a little bit here at the higher frequencies, but minus 100 dB and down is super clean. The THD versus frequency, I mean, this is THD, it's here. Yeah, everything is 0.017 and below. Even at higher frequencies, we saw some amplifiers reach like 0.1 or even higher than that. This is absolutely flat, no issues. Yes, we do have that typical rise at the high frequencies, but it's so small. And the absolute last thing that I want to show you is the frequency response and the phase. Phase is totally flat. Frequency response, this is, you can see on the left side, is 1 dB scale. So at 5 hertz, it is down by 0.1 dB. At 20K, it's down by 0.1 dB. I measured at 96K, so let's say 40 kilohertz. At 40 kilohertz is down by half a decibel. I mean, can you get anything flatter than this? Probably like micro precision or something, but yeah, it's typical amplifier flatness. 20K as flat as a DSP. So, in summary, is this the best amplifier that Alpine ever made? Maybe, maybe not, but it's on the level of the best amplifiers. The best that I've tested, as I mentioned, the 3.5, the 409, and this one. Now, what is the difference between them? Where the F900 takes the edge, obviously, in channel separation, because it is a dual stereo, so it's two different amplifiers. Another thing is the consistency between the channels, because with hand-picked parts, with all the discrete components, all channels perform almost identical, which we cannot say about other amplifiers. So in 2025, is it a good choice? Because you can still buy these in new condition. I saw them on eBay. They go for about 900 to 1,000 pounds, which is out there, but compared to super high-end amplifiers, it's not that much. Like micro precisions or Brax or I don't know, other amplifiers will run you, I don't know, probably 5 times as much. So would it be smart to buy something like this today? In my personal opinion, no, because it weighs a ton, it's massive. It takes a lot of space. But to be fair, the new Brax amplifiers are as heavy as these. Obviously, they will have much more power than this one, and the form factor is going to be probably smaller. The weight is kind of similar, so I don't know. But coming back to the same question I had in the very beginning about ignorance being bliss. When you're ignorant, when you don't know how it performs, you have very high expectations, and I had very high expectations for this amplifier. Am I disappointed? No, because I have, to be honest, really high reference levels about how amplifiers should measure. Even if it's slightly worse than a few amplifiers that I already have, I'm still super happy how it performs. And considering the fact that this is a brand new amplifier with film and everything, and 3.5 looks like this. It's kind of no-brainer which one you're going to be running, even if it's going to take a lot of space. I don't care. I want this in my car. So this was a journey. Frank, again, you're my man. Thank you so much for this amplifier. I cannot express in words how grateful I am for literally everything that you sent me, that you gave me. Your first gift with all the Alpine speakers and everything was the kick that pushed my channel into a different level, and now with this amplifier my build is gonna go into a different level. So Frank, again, thank you very much. And all of you guys, if you stay till the end through all my rambling, congratulations. And I hope that the gear that you have means to you as much as this amplifier means to me. So thank you very much for watching, guys, and I will see you in the next one.